Please let me know if you can see my screen.
Yep, I can see your screen.
Yep, awesome. Yep. So hello, everyone. Welcome to today's talk. So the topic of the talk is using big data and open source to win a war. So before we dive into the topic, a brief introduction of myself. So I'm Sohail Sankanur. I'm part of the data and digital team in Telstra Purple, currently working out of Melbourne, but in relation with teams in Perth and Sydney as well. I have been working in the big data space for about 3 years now. I have done a couple of projects as a SOAR architect. In fact, right now I'm doing a project as a SOAR architect for driving MSSP capability inside of Telstra Purple. So I've found a couple of security vulnerabilities. And for people who don't know what's bug bounty, it's basically you find a security loophole for a major tech organization like Facebook, Google, and stuff like that. And you submit it to them. And these bugs should be critical in terms of security use cases, which means there has to be direct impact on the customer data or direct impact on the brand reputation. And once you give these bugs to these tech companies, they reach back to you and you help them to fix it. And then they give you a bounty, which is some sort of an award, which ranges between a couple of thousand to about 10 million US dollars. I have done a couple of certifications in the past couple of years, mostly around Azure Databricks and Elastic Full Stack. So I just got my Elastic Certified Analyst badge a couple of months back. So right now, full stack. Working in cybersecurity for about 3 years professionally, but I have been doing research for about 6+ years. So I am usually defensive during the day, but do offensive stuff during the night. So before we dive in, a quick disclaimer from my end. So we will be talking with regards to today's topic from a technology standpoint only. All facts and figures which are used in presentation as examples, they are from reliable sources on the web, mostly from international journals and international news channels. Also, during this presentation, I'm not supporting any international or national political interest. Everything is with respect to technology itself. And the last point, I've just left it over there because there's a lot of things happening in Ukraine, Syria, Afghanistan, and a lot of places. So, yep. So before we get into the today's topic, the main point of discussion is what is big data. So big data is usually a confusing term because what is big in big data? So because of this, Gartner basically came out with 5 Vs. You might find different Vs. Maybe some are 3 Vs, some are 2 Vs, some are 10 Vs, but Gartner standard was put 5 Vs. So if these 5 Vs are satisfied in big data, in any sort of data, you can classify it as a big data. So the 5 Vs are volume. Volume specifies how much amount of data we are dealing with. Companies are usually producing data on a minute basis, on a second basis, sometimes millisecond, or sometimes it's on a daily basis. So how much data are we dealing with? Are we able to store it on disk? Do we need a server? Do we need cloud? Do we need like a huge infrastructure to store it? So all these questions are kind of thrown at the data. And based on the answer, we kind of segregate data or segregate that specific use case and see how much volume is there. And then there's variety. So variety is basically if you go into an infrastructure or if you go into a solution with a lot of technologies, a lot of open source tools, a lot of proprietary tools, there are many sources. And from all these sources are producing data. So these different sources have different formats, they have different schemas, they have different structures, they have different governance policies, rules, and stuff like that. So variety is with respect to how many sources are present and from how many places we are getting that data. So based on that, we look into the format schemas and stuff like that, and we look at the variety. And then there's value. So data is big in big data. So the value which data can provide us is huge. But usually as big data analysts, engineers, or scientists, usually what we do is we see how much it's helping operations, how much is helping the discovery, insight, search, analytics. So these kind of stuff, we basically look at the data and we see how much impact we can do for these teams inside an organization. And based on that, we basically analyze how much value we are deriving from that data. Is it worth taking that data out, moving it, because data has gravity. Movement of data from one system to another costs money. So we look at the value, and based on that, we actually classify data as big data or just normal data. And then there's velocity. So velocity is with respect to how the speed in which the accumulation of data is happening, or the speed in which data is being stored, processed, and retrieved. So in some cases, velocity is huge. In some cases, velocity is small. So if there are any data people on the call, there's something called OLTP and OLAP. OLTP, for the non-technical resources, OLTP is basically transaction-based. So say, for example, your banking systems, in these type of data sources, there's continuous communication with the databases. So say, for example, somebody on the call would just buy a coffee during this webinar. So that transaction has to reach the bank and state that, yeah, there is some amount of money which is being deducted from that specific person's account. So that's with respect to transactions. And then there's analytics database, where you don't keep hitting the database or the data store again and again. You hit it only a couple of times. And that's with regards to your analytics part of the thing. And then you have the veracity. So veracity is with respect to the truth or the accuracy of the data. So data is usually sometimes it's accurate, sometimes it's to the point, but sometimes the information which we get out of the data is not reliable. So we look at the veracity and see how reliable that data is, whether we can rely our business on that specific data. So this is just a brief of big data. And diving into the core topic. So what is cyber war? So in the kind of the topic for today's webinar, I just mentioned it as war. But then war is basically when two nation states or when two governments are fighting with each other to see who's more powerful, or to basically take a sense of power. But countries, nation states, and governments, all of them are kind of moving towards cyber warfare, because war is not an easy way. It's really expensive for war to happen. So what is cyber war? Cyber war is basically an action which is usually done by a nation state or a multinational international organization, and that's basically done to damage computers, national secrets, information, networks, and services. So if basically any nation state outside of Australia, or any international organization outside of Australia, if they are inside Australia for that matter, but inside Australia they have governance, so it's pretty easy. But outside Australia, if any nation state or any massively funded organization is kind of trying to damage computers, steal national secrets, it's trying to retrieve customer information, it's trying to retrieve information of the people living in the country, it's trying to disrupt network services so that people, there's chaos, there's a lot of problems which happens on ground. Any kind of interference with this in the government is considered as a cyber war, and usually anything which is done to national secrets, it's considered as a state of war. So if another country basically tries to target systems where national secrets are stored in Australia, Australia can declare war on that nation. So why countries are kind of leaning towards the cyber warfare and not towards the traditional warfare is because of these reasons. So these are basically the advantages cyber war gives with relation to war. The first point is cheaper. So cyber war is much cheaper than normal war. It can be done at fraction of the cost. War is really expensive. You have to have people, you have to have a lot of weapons and stuff like that, and there's a lot of human life lost. So war is really expensive, but cyber war in regards to war is much cheaper. There's a much higher impact if a cyber war is done. So cyber war creates a much higher impact with respect to a war. Also, the advantage with cyber warfare is you can actually be dormant and do a cyber war. So basically, there's lesser interference from international organizations and groups and stuff like that. If a country tries to do a cyber war by being dormant. I'm sure some people would keep getting questions. So if possible, you can just leave questions in the chat, and I'll get back to it once we end this session. So we have in cyber warfare also there's higher impact, and the third point is limited collateral. So collateral damage is really it's a really complicated topic. It depends on what collateral damage is. Sometimes collateral damage sometimes countries and governments just refer to collateral damage as human life, but sometimes even it's even data and stuff like that. That's also kind of referred to collateral damage in really developed countries like Australia and the other Commonwealth nations. But usually in cyber war, with respect to human life, there's a lesser collateral damage. If a nation, if basically two nations are in war, only with respect to human life, there's higher collateral, but in cyber war, there's lesser collateral, which again comes back to the previous point where there's lesser interference from international groups, organizations, and basically all the kind of peace organizations and stuff like that. Also, in case of cyber war, there's no responsibility. So if a nation state, if any nation state tries to wage cyber war on another country, nation, government, or company, if they do it in a dormant fashion, usually it can be done with limited or no responsibility, which means, say for example, a country tries to attack another country. If the thing is done in a very dormant fashion, the attacking country can just put their hands up and tell they have never done it. Also, cyber war tries to weaken national assets, which it's really difficult to do in warfare. So national assets is with regards to weakening governments, weakening the trust in the governments, which basically results to a complete downfall of power. So with the help of cyber war, in a very cheap fashion, we can basically try to weaken national assets, and we can trigger a revolution, which is kind of correlational, the last 2 points. So trigger revolutional is basically once you do a cyber war and you try to cut relation between the governments and the people, so people start trusting the government less. So this can it can mess up with the politics, it can mess up with the governments, and this kind of creates confusion in public, and it leads to chaos in the country. Yep. So before we dive in, just a couple of major cyber war attacks in the past maybe 10 plus years. So in 2010, there was something called Stuxnet. So Stuxnet was a code which was used for waging war in Iran. So this code was actually used to kind of interfere with all the nuclear operations in Iran. Usually, if you interfere in any country's nuclear operations or research, it can be considered war because it's a very sensitive thing for any country. There are speculations that Israel has done it. There are speculations that US has done it. But then somebody has done it. It was definitely not a one-man's work. The code was very complex. It had to include thousands of people working on it, millions of dollars spent, which means only a nation state can fund these kind of activities. So Stuxnet was one thing in 2010, which was interfering in Iran's nuclear operations. And it gained a lot of traction. In fact, there are movies on it. Between 2016 and 2020, a lot of people would be aware that there were Russian actors which were interfering in US, Canada, and Australia elections. This was with regards to the Facebook controversy and the company Cambridge Analytica. So these two were kind of the scapegoats. And with the help of these technologies, there were interference in multiple elections around the globe. In 2021, around May, the CEO of Telstra had announced that there's a critical hack on the critical infrastructure was being hacked, and there was some amount of private data losses, which included there were some amount of SIM card information, some amount of phone numbers and stuff like that, which were pretty medium impact stuff, which had been leaked out in that attack. And also in 2022, this was just a couple of weeks back. So ACSC is basically Australia Council for Cybersecurity, and these guys had announced that there were some attempts to actually try to steal top secret military information. In fact, these guys keep releasing these articles every day. So basically, somebody is trying to steal military information on a weekly basis, but they're trying to protect it as much as they can. So moving from the examples. So end of the day, we should know that cybersecurity and cyber warfare is not only a cybersecurity use case, but it's also a big data use case. So both these spectrums, cybersecurity and warfare, it can be solved using big data technologies. And when we talk about big data, in case of cybersecurity and cyber warfare, we actually rely a lot on observability data. So what is observability data? Observability data consists of 4 things, which is log, events, metrics, APM, and uptime information. Logs and events are basically any type of any event which happens on a computer is logged somewhere. So if a person is actually just moving a mouse somewhere, that information is being logged onto some file. these logs are basically shipped back to a centralized source, or these events are shipped back to a centralized source, depends on whether it's a computer or server and stuff like that. And then you have metrics, APM, and uptime. Metrics is basically any type of metric data with relation to software, which is consider how much RAM is being used. Or say, for example, for a normal person with a computer, it could be whether the camera is on or not and stuff like that. So these are metric information, which is shipped back to a centralized source. APM is application performance management. So when you are actually accessing any sort of web application, or when you're accessing any sort of application on the internet, say Facebook, Google, or whatever, internal Telstra applications, these applications are hosted on a server. And there are performance management logs which are taken from that application, which is basically we are looking at how many people are hitting the application at a given time, whether the application is lagging at a given time, whether there's some sort of a DOS attack and stuff like that. So these are basically the APM or the application performance management data. And we have uptime. Uptime is just to look at the health and to see if the service is active. So it's basically a ping request which is sent to the computer or the service to see if it's active or if it's down. So all these observability data, we actually bring it to a centralized source, and we basically observe it. So we look for various we look for various flags in the data. We look for if there's any kind of threat actor, if some malicious activity is taking place, if something is abnormal, if there is some abnormal behavior which is happening in the customer's computer or systems. So when we have observability, a lot of people, maybe around 10 years back, came with the question is, while you actually observe, why not protect? So why not have the additional layer of security for over the observable data? So before I dive into some security systems, let's talk about endpoint. So I'm sure this call has a lot of people from different sectors. Some people are developers, some people are security analysts, some people are maybe cybersecurity operations people, some people are security architects. So everybody has a different definition for what an endpoint is. So I thought I'll just keep this slide over here and let you know that when I'm talking about endpoint in this specific webinar, I'm basically talking about any device which is physically connected to the network. And that could be wide area network or your local internal network. And these devices could be laptop, desktops, mobile, tablet, any sort of virtual environment, any sort of EC instances on the cloud and stuff like that. So any device which is connected to the internet and which is consuming the internet to do something, we classify that as an endpoint. Yep. So diving into the main stuff. So there are a couple of security systems. It's really the complexity of these security systems is huge, and basically I can keep separate sessions in the future to explain each and every security system. But to just to give a generalized overview of all these systems so that we get a rough idea of what happens in cyber warfare space, is there something called SIEM. So SIEM stands for Security Information and Event Management, and it's the go-to system for any security operations or any MSSP provider or any sort of mega organization like Telstra Purple to secure the customers' devices or the government's devices. So SIEM basically gives us a centralized data store, like you can see in the picture on the right. So it's basically a management tier which acts as a centralized data store, and we get data from multiple devices. So that could be firewalls, that could be normal servers, that could be a normal rack sitting in the office, or that could be critical government systems, or even normal computers like we have in front of us. So once we actually get the centralized data into a management tier, we perform manual detection and response in real time. So basically over this data, we can actually perform searches, we can analyze this data, we can see for any sort of malicious behavior and detect it. And then the list goes on. We can use machine learning to actually detect any threats in real time and stuff like that. But roughly what happens is there's detection. And once there's a detection which happens, there's a response action which is done. And usually this is done by a human being. And this human being is basically an operations person in the security operations center. So he basically looks at the detection, and based on that, he takes actions to respond to that specific detection. So security operations is really complex in terms of log management, because log data is not something which is generated every hour or so. It's actually generated on a millisecond basis. So sometimes there has to be searches which is done on historical data. And security operations would always be doing that on a daily basis, which is searching historical data to see any threat actor has entered the environment or stuff like that. And SIEM basically allows us to perform searches over historical data. And once we perform searches over historical data and we see detection or there are manual rules which are written, there are basically they are basically sent as alert. And this could be in multiple forms. This could be in API request to other systems, or this could be in normal mail to the security operations guys. This could be in a form of a weekly report to maybe the manager in the SOC. So this is the brief of a SIEM. Next, we have EDR. So EDR basically stands for endpoint detection and response. Now we talked about SIEM. SIEM gives us visibility into the entire customer devices. It gives us visibility into all the devices because we have logs, metric, APM, all the observability data coming to a centralized source. But once we get visibility, we can perform detection and response manually, but we can't do it in an automated or a continuous fashion. So EDR stands for endpoint detection and response, which is usually working on top of a SIEM. So EDR is actually powered by SIEM, but it's performing automated detection and response, which it's an additional capability on top of a SIEM. And then we have XDR, or extended detection and response, which is just an additional word for basically an additional enhanced feature for EDR. So in EDR, like the word says, it's only endpoint detection and response. So we can only basically do detection and response automated capabilities only on an endpoint, but we can't do it on varieties of different sources, which is basically network sources, any sort of a firewall, any VM service, third-party databases, third-party applications, and stuff like that. So XDR is basically an EDR with an enhanced or a multitude of sources. So we're getting data from a multitude of different types of sources, which includes endpoint, cloud VMs, third-party databases, networks, firewalls, and it depends on what XDR you're using. So once we have all these endpoints, multiple endpoints, once they're sending data, it's again powered by a SIEM at the end of the day. So we can perform detection, we can perform enhancement investigation, and we can respond and remediate to any sort of malicious event which happens. So XDR usually has, roughly XDR usually helps cyber defensive operations to detect. Once the detection happens, there's investigation, response, and remediation. So say, for example, an analyst detects that some malicious activity is going on the background. Once he does that, he has the ability to investigate into it, to basically read it, what's happening, or to look into what's happening. And then he can basically enrich it with different types of information. He can investigate on it, and then he can respond, which is maybe blocking that specific system, quarantining the system, throwing the system out of the network temporarily, and stuff like that. So it would not be fair if I talk about all the security systems without talking about Elastic. So Elastic is a search company, but then it transitioned heavily into security space. So the basic function of Elastic is search. And in fact, if people are interested in Elastic, there's a talk which I gave, which goes by the name of Elastic 101. And I think the recording would be there in the share and learn session. So please feel free to refer back. But Elastic helps us basically bring all observability data from multitude of sources into one centralized source. And once we have it in this centralized source, we can perform searches. We can do a lot of other stuff. And because we can do a lot of other stuff, a lot of open source, and Elastic is open source. So basically all these people from the cybersecurity and cyber warfare field. So these guys took Elastic, they tweaked it into their specific use case, and they started using it for the security security as a solution. And then Elastic as a company, they invested heavily in that area, and they made it into a complete solution, a complete fully powered solution. So roughly, just to go ahead, before we go ahead, a rough thing of what the Elastic Stack provides. So Elastic as a product has a fleet of products which can be deployed anywhere. We can deploy it on a box. We can manually deploy it on bare metal. Or Elastic offers the SaaS capability recently, which is the most powerful capability. Basically, you just do a couple of clicks and you have an environment running, rather than looking after deployments, upgradation, CVs, what versioning and stuff like that. SaaS is available. It's SOC 2 certified, so we can use it in our security operations. The different products which Elastic gives us is Beats and Logstash. So Beats are very lightweight agents which ships the observability data back to the centralized source, which is Elasticsearch. So on top of that, you see Elasticsearch, which is the heart of the stack. It's the centralized store. where we basically store, process, analyze, and search on data. Beats can be deployed anywhere. So say, for example, I deploy an Elasticsearch on an AWS service, and I deploy Beats on all our systems. So all our systems start sending observability data to the Elasticsearch on the AWS service, and then I can connect to Kibana to that specific Elasticsearch system, and I can perform different types of searches and stuff like that via UI. So I don't have to actually know code to be an Elastic expert. In fact, you can actually just take a certification on Kibana, which is the Elastic Certified Analyst exam. On top of the stack, Elastic came up with a lot of different solutions. For today's, we'll go into observability and security. So observability, like I mentioned, it's basically observing with all the observability data, and security is basically built on top of observability. So the saying which goes, while you observe, why not protect? So basically, security use case was on top of observability. This is a very brief very kind of brief introduction of Elastic. If people are interested, please feel free to refer back to Elastic 101. Now let's talk about Elastic Security. So Elastic Security gives us there's something called Elastic Agents. So Elastic actually, as a company, they actually acquired a company called Endgame. And Endgame had these kind of specialized agent or specialized lightweight data shippers. So Elastic basically used that, it enhanced it. And now the agent helps us in prevention and detection at host level. So if there's a malicious actor, if there's a Mimikatz or any sort of activity which is running on the network or the system or the endpoint, it can basically prevent, detect, prevent and kind of quarantine and prevent and kind of get rid of it at the host level. You don't even have to communicate back to the servers or the security operations and stuff like that. So roughly, Elastic Security, there's prevention, detection, and response at host level, and using the entire Elastic stack. So if the security event is of a really complex nature, all the data can actually be shipped back to the centralized Elasticsearch, which is usually deployed inside a security operations center. And once all the data comes back, the operations analysts, who are basically cybersecurity experts, they can perform manual searches, they can perform analysis, they can perform they can use pre-built detection rules, they can use machine learning, they can use advanced analytics, they can use whatever kind of skill they have, and they can act on the detection and response capability. So roughly, Elastic Security can be put into the XDR bucket or the extended detection and response bucket. Yep. So the last thing for today, in terms of technology wise, is something called SOAR. So SOAR actually stands for Security Automation, Orchestration, Automation, and Response. SOAR is nothing but everything we talked before, which is we have SIEM, XDR, EDR, and basically every other security device on the world. Taken that and you add automation to it, and that's basically what SOAR does. In terms of security, there's detection and response. Detection is basically looking and flagging that, yep, some malicious activity, some threat actor is there on that specific system. And there's response. Response could be blocking that specific system out of the network, or quarantining the system, or basically taking action on that specific code which is performing malicious activity, basically deleting that file. It could be basically formatting the computer in worst cases. But between the detection and response lifecycle, the operations guys, or the people on the floor, they do a lot of work, which includes basically enrichment of data, getting more data, enrichment, and kind of which includes basically looking at various reports to analyze what has been detected, because malware is really complex. Malware, rootkit, or any sort of malicious activity which happens, it's really complex. It's not easy for one person to understand. So there are a lot of activities between detection and response. It could be referring to threat intel databases, which is a centralized database these companies like Kaspersky and stuff like that provide. And what happens is these databases has a really crucial information with regards to the code and stuff like that, which in security terminology is called IOCs. So SOAR basically helps us do all these steps between detection and response. It gives the analyst to create something called playbooks. Playbooks are basically a set of actions which could be done and which could be automated by security analysts. So rather than them doing it manually, they can actually create a playbook for doing it. And again, the same thing. We have detection, we have response. So in the playbook, we have detection, response, all the activities in between. Create a playbook, keep it up and running, and everything's automated at the background. So security operations is a very time-sensitive work. it's a really like kind of it's I would say it's a really hard job. It's not easy for a person to work in security operations because they work kind of round the clock. They have multiple alerts being thrown at them, and then they have to keep learning about new terminologies, new threats. They have to keep learning about new malwares and stuff like that. So it's a really hard job. And there are a lot of alerts which keep coming inside of security operations because nowadays the threat landscape is not limited. It's become massive. There are attacks which are happening every second, every minute. People keep getting spam calls. I'm pretty sure somebody would have got a spam call today in today the entire day. So we have alerts are basically alerts are nothing but you can just take it as a ticket which are being thrown at the security operations guys. And because there are a lot of alerts thrown at them, they get something called alert fatigue, which is basically sometimes they're reading at the same alert for maybe 100 or 200 times, and because of that, they actually get tired. And they're not using the skill set. They're actually wasting their time. And that way, the security operations would not be delivering the best things to their customers or the government. So playbooks help in that. You can just spin up a playbook. Security analyst can come. He can write code in Python. He can just drag a couple of nodes, drop it in a playbook, and run it as a cron job. Also, you can actually do that, and that basically allows the analyst to basically automatically close alerts which are of not really critical and stuff like that. And also, SOAR helps us to monitor SLAs, which is very critical for the security operations. So any sort of monitoring with regards to the ticket closure, how much time the analysts are spending on one specific case and stuff like that, those can be monitored to keep helping the operations perform better day by day. So like the Venn diagram on the right, we have SIEM, which is the core part. EDR and XDR are powered by SIEM. And we have SOAR, which is powered by everything in the security landscape. So we can use EDR, XDR, we can use SIEM. Some security operations are so complex that they have SIEM and EDR and XDR deployed with maybe 100 other security devices. So all this can be combined with the help of SOAR. Also, like I told, these things are really complex. So maybe in the future, I could actually keep separate sessions on each of these technologies. But for now, yeah, this would do. Yep. So now we have learned about a lot of security technologies, but we have not come to the main topic of today's conversation, which is are these technologies warfare ready? Can we use this in cyber warfare, not in cyber security operations, not for just normal not for normal public devices, but for really critical devices like governments, maybe military operations and stuff like that. Because usually in cyber war, there's a quote which is it's not an if, but when a cyber war will happen with regards to any country. So there are two core ways to do these technologies warfare ready. One is something called MITRE ATT&CK framework. Just an important note before I get ahead is a lot of people on the call might be confused between this MITRE and the MITRE 10. So I'm not talking about the MITRE 10, which is the house hardware shop in Australia. This MITRE is totally different. So MITRE here stands for Massachusetts Institute of Technology for Research and Engineering. It's a kind of a non-profit organization which is based out of the US. It has helped many large organizations and the US military for developing open source technologies and for developing a lot of stuff for warfare operations for the US military. So roughly MITRE came up with something called an attack framework, which is a globally accessible knowledge base. It's basically a knowledge store of varieties of tactics, techniques, and procedure, which are also termed as TTPs in cybersecurity world. So tactics are nothing but what the offensive person or what the adversary is trying to do. Whether like is he trying to just hack one person's computer? Is he trying to hack the whole nation's computers? Is he trying to steal crucial data from military? What is he trying to do? And then technique is based on the tactics. So say for example, you have a tactic of an adversary is basically trying to mess with nuclear operations. What techniques is he using? Is he using C++ code? Is he using Python code? How is he delivering that code to that specific system? So these are techniques, and then procedure is the exact step-by-step activity which is being done for basically looking after the technique. So this is basically linked. We have MITRE has come up with something called TTPs, and there's basically it's an open source and basically accessible knowledge base which anybody can access. The way to access this is basically just go to attack.mitre.org, or you can just put this in Google and you'll get the first link as the attack framework. And then we have something called Killchain. So this was actually designed and developed by Lockheed Martin which is an American aerospace. It's an aerospace arms and defense group inside the United States. So Lockheed Martin came up with something called kill chain, and it gives the progression of a cyber criminal or the attack progression which happens in a major or a heavily funded cyber attack. There is direct linking of kill chain with TTPs. Also, the advantage of kill chain is if technologies are working with the kill chain activities, it gives proper visibility in the attack chain. And basically, the operations guys or the people who are in the defensive side can actually look at which part of the chain the attacker is at, and they can take responsible actions based on that. So roughly, kill chain it has 7 core steps. Say, for example, we have an attacker who's actually attacking Telstra, just for use case. So the 7 steps would be something like this. The attacker does something called reconnaissance, which is basically trying to find as much information as possible with regards to Telstra, which is finding employees, finding their details, finding if they're married or not married, what time they wake up and stuff like that, and basically finding information about the company, what revenue it is, how much impact it can cause by attacking Telstra and stuff like that. Once he does reconnaissance, there's a motto with which the attacker is trying to attack. So based on that motto, he does something called weaponizations, which is basically finding an exploiter backdoor, or it's basically delivering any kind of payload, which is roughly you can just consider the attacker is writing code to do bad stuff for the company or the government organization. And then you have delivery. Delivery can be done in many ways. Before it was done via USB and stuff like that. Nowadays, you can have email. So maybe the attacker can call everyone in Telstra and say, there's a really good package which Telstra is giving to its employees. So just click on this link and you get the holiday package. And basically, some person in the organization clicks on the link and that's it. They're in. And once you have the delivery, you have something called exploitation, which is exploiting that specific vulnerability, which again draws back to the first stage, which is reconnaissance. And again, this is a chain. So usually an attack happens in this progression itself. So exploitation is basically taking advantage of whatever information that attacker has about the system, processes, applications, and stuff like that, and basically exploiting it for personal or government benefits. And once the exploitation happens, it's basically inside the network, inside the system, inside the crucial infrastructure. He does installation, which is basically installing his code or exploit into that system. And once the installation is done, he basically has full command and control over the system to manipulate the victim. So basically, he can do anything. He can just shut down Telstra network for 10 given days and stuff like that. So command and control is basically taking full command and control over all these critical infrastructure. And then you have hands-on actions on objectives, which is basically getting really crucial access or basically trying to accomplish their initial goals, which again goes back to reconnaissance. So before the attack progression starts, there's some goal with which an attacker does all this. And these are the 7 steps which occur in an attack progression. So the way the way we can make all these technologies cyber warfare ready is by embedding MITRE ATT&CK framework and kill chain into all the security technologies. So let's actually talk about a couple of sample architectures. Just a quick call out is there are multiple technologies which are involved in designing cyber defensive war ready solutions. So I am not taking a demo because showing multiple technologies would look more like a commercial than a demo. So I thought I'll just go with the sample architecture. But if people are interested in a demo, please leave it in the chat and I would consider it. If people are willing to participate in the demo, maybe you can just reach out to me on Teams and we can work that out. All right. So my first demo is sort of an open source or sort of an open kind of architecture. So most of the tools used over here are mostly open source. So inside the security inside a security operations center, we have a lot of tools. We have Splunk Phantom. We have different types of SIEM, Sentinel-1, CrowdStrike, FireEye, Palo Alto, or over 300 other plus products. Say, for example, we are walking into a really complex SOC. Say, for example, you're walking into Telstra SOC, which is, I think, most complex SOC inside of Australia. We have something called the Hive. So the Hive is actually an open source. It's an open source case management system. So all the cases which come from all these existing security operations systems comes to the Hive, and it basically does case management, which is keeps it in forms of tickets and stuff like that. The Hive is basically connected to Cortex. Cortex is an open source enrichment engine or an investigation engine. So once all the data comes into Hive, Cortex basically takes that data and it tries to find more information on that specific thread, which is basically contacting to all third-party vendors like VirusTotal. There are a lot of third-party vendors in cybersecurity where you can contact them to get really really intensive kind of operations data, which can help you in your daily action or resolution of cases and stuff like that. So Cortex does collect all these metadata. It enriches all these cases with really rich metadata. And then the Hive is also integrated with MISP. So MISP is actually an open source threat sharing platform, which basically means, say we are working for Telstra security operations and somebody else is working for AT&T security operations, which is in the US. So some sort of attack is happening in AT&T, and these people find maybe 10 IPs which are trying to do some sort of a DDoS attack. So they can actually take those IP addresses and update it in the MISP or the open source threat intel databases. And we at Telstra can actually see that these IPs are malicious. These guys are trying to do something to disrupt services. So we can actually put it in a block list and stuff like that. So MISP is basically a global threat intel sharing platform. It's open source free, and mega organizations are using it, including Telstra as of now. The Hive is using Cassandra as a database, which is basically a GraphDB. And for all its search and analytics, the Hive is actually using Elasticsearch on the background. And then you have Shuffle and n8n.io. So these are basically all orchestration engines, which are open source orchestration engines on which you can create playbooks and stuff like that. So all the security operations, which you can see over here, people sitting. So consider these are security operations. These people actually access these playbook capability open source tools, and they can create playbooks and run it as cron jobs, or they can trigger it manually if they see some malicious activity, or basically they have multiple ways to configure and run playbooks. Once they run these playbooks, all these playbooks run on the Hive, and Cortex is used for all the metadata enrichment. So roughly, this whole solution can actually be deployed inside the security operations. And like I told, the demo is really complex because I have to show a lot of tools. It's going to take some time. But roughly, all these are open source tools. I'm going to share the slides. You can actually go to the GitHub pages of each of these tools and refer it to see what these things do. But more than open source, I'll actually get into one of the core products. So Telstra Purple is actually trying to do this work, wherein we are actually using Palo Alto Suite for setting up a SOAR infrastructure or setting up an MSSP service to customers. So Palo Alto has a lot of products and solutions which they've come up over the past years, and they basically sell it as Palo Alto Suite, which is basically a suite of products. You can see something called Cortex Data Lake. So you can consider this as a SIEM, roughly, which is basically shipping all observability data from multiple endpoints, servers, cloud data centers, branch, any devices which is connected to the internet or connected to any sort of internet networks. We can take observable data to it and throw it into the data lake, which is an unstructured way of just storing lots and lots of data. And XDR runs on top of data lake, performing manual detection and response capabilities, automated detection and response capabilities, and stuff like that. And XDR is connected to AutoFocus. So similar to MISP, which is a threat intel database, AutoFocus is a threat intel cloud database, which is actually sold by Palo Alto as a service for a given cost. Wherein you have basically Palo Alto is not just selling the service; they themselves have security operations. So they themselves have research teams in security working and filling the database with really good threat intel information. And basically all the other customers, Palo Alto security operations, or even if we are going to use it, basically all of us will keep filling this with this database with critical information, which is going to help us in defense. So XDR basically pulls all these threat intel from AutoFocus, and it does all the detection and response work on the background. And then you have something called Cortex XOR, which is basically the SOAR platform, which runs on top of XDR. And like I mentioned, it's connected to all other devices. So it's basically taking all these devices and giving the automation capabilities for the Security Operations Center. So the Security Operations Center guys, they basically just log into the SOAR. They can manually log into the incidents. They can look into different steps of action. Because these are all cyber warfare tools, they can actually see attack progression on a kill chain. They can see MITRE TTPs on the specific IOCs or indicators of compromise, which is basically malicious IPs and stuff like that. So roughly, this is the Palo Alto suite. It does run on top of all the security infrastructure which a company will have. And rather than these analysts logging onto hundreds and hundreds of devices on a daily basis, they can actually just log onto one device, which is Cortex XR, and do the complete control and command and control and execution of the entire security operation with the help of that specific technology and with the help of with the kind of power of automation. So we are almost coming to an end. So I'll leave this platform to just say that some people in today's talk would have understood a lot of things, or they'll directly be able to correlate to what I was talking. And some people might have not understood some things, or maybe there will be people who wouldn't have understood anything. That's not a problem, because these topics are really complex. So one session is really hard. 45-minute session is really hard to give out all the information. But nonetheless, if you are excited in working on something like this, you would have seen a couple of posts by Trent, which is with regards to Elastic partnership. So Telstra Purple is actually doing a lot of work for partnering with Elastic at the background. And because of that, Elastic has actually given access to their portal, which is a 1-year learning resource access, which costs roughly around $6,000 US. But for Telstra Purple employees, it's free. All you have to do is just learn and get certified. So if you're excited to work on something like this, you can actually reach out to me, or you can reach out to Trent himself for getting access to the portal. There is also an Elastic 101 talk, which I did a couple of months back, and that might be there on Share and Learn. And if you want to work on this, you can directly reach out to me, and I can get you started. So I think if Trent is on the call, he can maybe add in a couple of points here.
Thanks, Sahil. Yeah, just calling it out to everybody. If you're interested in Elastic, interested in these topics, definitely join the data and AI team site. We've got a pretty good community there. Sahil's very much in the data team, as well as that cybersecurity space as well. And it's really nice to see Sahil connect the dots for us here at Purple. So thanks very much, Sahil, for what you've spoken to today. The Elastic subscription stuff, the relationship is just starting to develop. So if you guys are really interested in, getting interested in learning Elastic, I can obviously reach out to those guys and get more subscription access for everybody. So we've got about 15 seats, but they're more than happy to go well beyond that. So I know there's quite a few people on this call. So if you want to jump on board, just reach out through that channel and go from there. So Sahil, back to you, mate. Thank you.
Yep. Thank you. Thank you, Ken. Thank you. And before we end off, any questions? Maybe you're going to open the chat for now. Or if anyone has questions, please feel free to unmute and ask. I'll be happy to answer.
So Sahil, there was a couple of questions in the chat. I'll read them out to you.
Yep.
And maybe you can answer them off the top of your head. They're more holistic questions than anything else. But the first one was from Damien. There have been multiple instances of cyber attacks over the last few years against Australian government agencies. Do we consider ourselves in a constant state of undeclared war with multiple countries who have hosted or encouraged these attacks? So it's more of like a question statement to the general audience, but I'd love to get your thoughts on that, Sahil, as well.
Yep. So that's a great question, Damien. Yep, there has been multiple cyber attacks inside of Australia for the Australian government, and not only the Australia, there has been a lot of cyber attacks for all the Commonwealth countries, UK, Australia, and Canada. And in some cases, Australia is actually working with US and the other Commonwealth countries to actually form defensive technologies. Or Australia is actually relying on really big organizations, for example, Telstra, to actually give services to them in sort of cyber warfare and cybersecurity space. So yep, we are a nation with a lot of resources, with a lot of people living over here. It's a developed country at the end of the day, so it's definitely a target point for a lot of other countries. I don't want to get into which country is targeting whom, but yep, Australia is a threat landscape in the cyber warfare space. There are a lot of countries outside of Australia who are targeting Australian citizens and government on a daily basis. So yep, we have to be cyber war ready. And I think Telstra is also doing a lot of work with the government for this work for this use case. Yeah. That would be my answer.
There's two questions here from Harsh, Sahil.
Yep.
Any implications for Australian companies that we should be aware of in Telstra and talk to customers about the recent Okta security breach? And Sahil, you might not know that off the top of your head. there was a link in the chat. And then the second part of the question, what should a non-technical customer-facing team members look out for or do when any such news comes out?
Yep. So with regards to the Okta security breach, I'm not aware of this because there are a lot of breaches happening on a daily basis. So I'm not really aware of this. But with regards to the second questions, which is what a non-technical customer-facing member should do, I would say the first thing is educate our customers or educate the general public. Maybe keep meetups like this, keep host events and stuff like that to actually show this to public, show this to youngsters, get them involved in this kind of work. That would be one thing. And one thing which we could do if such a news breaks out is, say, for example, we already have a really big security operations inside of Telstra, and there is some big attack like WannaCry which happened, but Telstra is not impacted. So that basically gives us some sort of a power in the market and power with the government to say that we are not getting attacked at any use case. And governments do love this. If one company is not getting attacked at all and all other companies are getting attacked, the government is going to go to the company and ask them for help. So that would be one thing. Maybe some sort of an advertisement or some sort of a call out to state that we have really hard cyber defensive operations inside, and we can actually leverage that to our customers and the government. And yep, I think Harsh has also kind of put a post with the Okta attack. So maybe I'll read this and I'll share my thoughts. But yep.
Cool. That's all the questions in the chat, Fred. Suhail, so maybe just to the people on the call, if there's a question, raise your hand or unmute yourself. Otherwise, we can stop recording here.
Yep, sounds good. So if there are no questions, I'll stop recording for now.